Okay, let us look at a case of feedback of Hs equal to 1. And we know that our Gs, as we recall before, has to be a polynomial of Z1s over P1s. Okay, so we know that to get a closed loop transfer function, for this one is the forward gain is KGS and the loop gain is KGS. So this can be represented as KGS over 1 plus KGS HS. And as HS equal to 1, so we can just say it is 1. So by knowing this is a closed loop function and knowing that GS is represented by this polynomial Z1 over P1, okay, so our YS RS will be K Z1S over P1 over P1S over 1 plus K Z1S over P1S. So if you simplify here, we know that this one we can put it here. So we get K Z1S over PS over the whole thing. This one we go to here, become P1S plus K Z1S over P1S. And this P1 can be cancelled with this P1, so we get this equation KZ1 PZ1. So we see that the number of positions of 0 for open loop and closed loop poles are the same, meaning that for the top you see only the numbers of 0, but for the bottom we see that the numbers of poles will be defined by the P1 here. Okay, because basically this one, the numbers then we can sum up, meaning that the order will be still maintained at P1. Okay, so characteristic equation for this one is just this value we equate to 0. So that's why this is the characteristic equation for this is a characteristic equation for HS equal to 1. Okay, let's look if HS is not equal to 1. HS equal to 1. So let us define G as Z1 P1 as before, and the H is Z2 over P2. So from here, we know that the open loop transfer function is just K1 Z1 and P1 P2, and the closed loop as just like this one, But now the value of G and H is not by putting the value of here and doing the same thing. Okay, never mind. Let's do it again. We see YS equal to HS for the closed loop. So we get KGS. So KGS is K Z1S over P1S over 1 plus K P Z1S P1S multiply the H now is Z2S over H2S here. So if we expand this one, this one, since this is so if we expand this one, so we will get let me find some space here. We get this one become, hang on, I just want to find some space here. Okay, here I put it here, YS over RS. So you get it to be K Z1S over P1S over this one multiply, you get P1S. This is, sorry, This is not H but P. P2 with P2S plus K Z1S over multiplied by Z2S. Okay, this one we remove it, over P1S P2S. So you see that this P1 and this P1 is cancelled, and this one will go up. So that's why you get KZ1 P2S P1 plus P2 KZ1 and Z2S. This is the closed loop transfer function for HS not equal to 1 but equal to, as mentioned here, this one. So position or poles of the closed loop depends on the number of poles and 0 and the K of the open loop transfer function. So position of the poles, if you see from here, the poles of the closed loop depends on the position of poles and 0 and K of the open loop. So we define now the root locus as a K, as it varies the closed loop poles, follows merely from a locus. For that, we define root locus is a locus of characteristic equation as K varies from 0 to infinity, meaning that we know that this is the characteristic equation. So the characteristic equation will give us the value of a root, and the root will depend on the value of the K. So if K change, then the root locus change. Okay. So let's say that KGH is equal to K sum of all the zeros, and the sum of all the poles. Okay. So it will depend on the value of G and H. So if we rearrange this one, we arrange from here, we take from this equation, we arrange equation. Let's say we name this equation as a A. If you rearrange equation A by putting the 1 on the right hand side, we get KGH minus 1. So minus 1 is actually a complex number. So if you draw minus 1 in the complex or the S-plane, this is the real value, or we call it as sigma, and this is the j omega or imaginary values. So you see that minus 1 is actually here. Sorry, I don't want to confuse you with the poles. So the minus 1 is here. This is minus 1. So this is a complex number. So you see that the magnitude of this complex number, the magnitude is 1, and the angle is either pi, if you look on the positive direction, or negative pi, if you look in the anti-clockwise direction, in the anti-clockwise direction. Sorry, in the positive value is the anti-clockwise, which is pi here, and the clockwise direction is the negative, which is minus pi. So that's why you can represent minus 1 to be a magnitude of 1 and angle of r pi, where r stands for plus and minus 1, 3 and so on. Because why this 3 and 5? Because for every circle, let me write here notes. For every circle, it will repeat for every 2 pi. So that's why you have 1, 3, 5, 7 and so on. So we know that from here actually is the basic for defining the root locus. So it can define into 2 conditions.